Now I'm very happy to welcome Dr. Andreas Leitner, because in a lot of times we speak about new ways to recycle polymers, and we speak about new possibilities. A lot of these possibilities are in technology readiness level 5, 6, 7 and something like this, and so we go a little bit deeper inside and look what you are doing in Schwechat. Last time when I've been there was extremely interesting, and so thank you for the inside view.
So, good afternoon, everyone. Mr. Chairman, thanks a lot for a kind introduction. Ladies and gentlemen, I would also like to thank Circular Value Convention, actually, to give us the opportunity here as OMV to give a presentation here. So, for those of you who do not know OMV, maybe one sentence. So, we are an Austrian/Vienna-based company which traditionally produced oil and gas, and since 2022 we are transforming into an integrated chemicals energy company with a strong focus on circularity. And together with our group companies, which also is Borealis is part. Borealis is known, I think, as polyolefin producer, and Petrom, renewable energy producer. We have a common target to reach net zero by 2050. And this is a really, really tough target. And I would like to show you today that we're actually a practitioner, and we always say we're also the walkers and not only the talkers. And if you take this away at the end of my presentation, mission accomplished. We have a turnover of 39 billion, around 21,000 employers. Yeah, and we are one of the bigger Austrian companies. Good. Good news is you have seen already a lot of today, but give me 1 second again to repeat the circular economy cycle. So we have basically 3 different types of feedstock, right? Classical oil, gas, so fossil-based. Then we use renewable feedstock, used cooking oil, HVO, hydrogenated vegetable oil, CO2. These are our new feedstock sources, old and new feedstock sources which we use. Then we have a chemical producer. This is our cracker, right? We make olefins. The olefins go ethylene and propylene to Borealis, make polypropylene out of that. And then, of course, here, one thing was already very important, I mentioned already before, the design of the polymers plays a critical role for the circularity. Now one might say, well, it's anyway logic, but I repeat it because it's so important, and with Borealis we have really the right people on board who are actually able to do so. So then the products come into your household. I'm pretty sure you all have used already polyolefins today, maybe without even knowing it. You can reuse it or dispose it. I think the CEO of the Grüner Punkt the Green Dot has nicely explained what's happening then. Waste collection, sorting, and then you have 2 ways, mechanical and chemical recycling. Mechanical, the chemical integrity remains, the mechanical part, right? And the chemical recycling, you basically take the polymers again apart into monomers, and you're back in the manufacturing loop. Maybe a little bit about absolute numbers. In Europe, every year, 54 million tons of polymers are produced. This is quite a big volume. And when you look here, more and more, yes, we make also circular polymers, but when you look on the challenge of circular economy, it needs industrial processes. We are not talking here about a couple of tons, we talk here about millions of tons. And in order to accomplish this, we have to have industrial processes, number one. An industrial process means also we have to be able to make money to invest into these industrial processes. Super important, and this is the journey we are on. So where's the feedstock coming from? In our company, we don't talk about waste anymore, we talk about feedstocks, because plastics are actually too valuable to just incinerate them or dispose them. So obviously you have the lightweight packaging collection we have seen before. Then we have the household waste, and then of course we have commercial and industrial waste. In the dark blue scheme, you see what's existing: sorting plants, waste splitting plants. The sorting plants you see on the top, the good fractions go to mechanical recycling and the respective applications, and the rest often goes to waste recovery plants. or cement industry. The green part, this is what we consider as the future requirements to go further, on the one hand, in mechanical recycling. We learned just before, better quality of feedstock, better quality of products, or to go into chemical recycling. And this does not exist to the extent which we need it. This is, we heard a lot about collaboration today, spot on, thank you for that mentioning, Karin. We also collaborate. We are not a waste management company. We went, for example, in Germany to Interzero and invest in a joint venture in Waldürn, big money to make feedstock for our chemical recycling. Super, super important. In sorting, we collaborate with Tomra. I name them because it's public knowledge. Why are we doing this? Because we don't have, obviously, NRs in our portfolio. But what is ReOil? And apologies, now it gets a little bit technical for a minute, but I hope it's understandable enough to everyone. On the left-hand side, you see we use a feedstock fraction. In our case, preferred polyolefins, can also be polystyrene, flakes, agglomerates, doesn't make a difference. We melt it in an extruder and it goes into our reactor, pyrolysis. Pyrolysis is heating up materials, exclusion of oxygen, you take the polymer apart, you have the monomers again, actually not, you have not monomers, excuse me, you degrade the chain to shorter chains, and then you have a sort of flash, and then on the right-hand side you see all the different type of products which we can actually directly use in our refinery and in our cracker. We can remove also of additives which were used to make the plastics conform to its application. We recover the oil waxes, very important, also to improve the ISCC plus yield, and some of the oil goes back in the loop. And as I described before, again, it goes to Borealis, cracking, and we are back in the cycle. This sounds very simple, but now comes the story. We are working on this since 16 years. Wolfgang Hofer, Dr. Wolfgang Hofer now, started in the lab with a flask melting plastic in oil, and checking out if this is doable. And here you see, 2009 it started in a batch plant. But of course, we want to industrialize, therefore we say we have to have a continuous plant which we can scale. 2013 was a smaller plant. 2018, we built the first integrated plant, integrated into the Schwechat refinery, where we actually tested, I think, every available feedstock in Europe which contains polyolefins. It's amazing what people did. Why did we do this? Because we want to make sure we can scale. We can scale and we have the parameters to scale. The next one here, 2024, we completed our ReOil plant with a capacity of 16 kilotons, 16,000 tons feedstock input, and we are just in the, as we speak here, in the phase startup. So far, everything going well. And of course, this is super exciting because not often you have also in innovation the opportunity to start up a brand new technology at this scale. And we have, of course, already plans for the next one, which is a 200,000 ton plant for waste input, right? And very good, I mean, because people always say, are we really working on the right things? For this project, we just received the Innovation Fund grant of 81.6 million. I tell you this because the press release came unfortunately out this morning, so very good. In practice, it looks like this. This is our latest version of ReOil plants. And when you go from the right to the left, I always mention one thing. You start in the waste industry, right? Here's the feedstock banker. You see everything nice and clean. We talk about industrial, no littering, absolute no-go. This is why we invest so much money in this. Then you have a conveyor belt to the pyrolysis. And here you go from the waste industry into petrochemical industry. Completely different competence profile. I tell you, people in a refinery hate smelly plastic. Yeah? Just as a small side remark. So now we are here. We have the reactor. What are we doing here? Of course, again, and even on this scale, we simulate, we test materials, and so on, different feedstock. But we also want to make sure that we fully understand the downstream part. We take out impurities, halides, nitrogens, oxygens. We take out there because we have to make sure whatever we feed into our refinery does not shut down our refinery. This is a no-go, right? So we're building also this, and then a hydrotreater at the end, and then we go back into the refinery, and we are there. So what does it need to do such a thing? It was 16 years. Now will ask me, how much money did you make the last 16 years with this? I don't give you the answer. But it requires a vision. It requires a strong belief that circularity needs to be resolved. And it requires a lot of money that you can do that. There's massive capex behind this, but not only capex, also a lot of enthusiastic people who want to work on this. And I can tell you, people these days don't join OMV because of the classical oil and gas business necessarily. They join us because of this. And with this, I would like to close here. Thanks for your kind attention, and I hope I could show you a little bit how practicing works.